So, does this thing work? Dop dop. Yeah, it works. I did lose one thing though. Make that again. There. Yeah. Okay, so at some point this is being called with the point at minus 9 million. And I really want to know what happened. What happens then? I guess I switch to YouTube. Larger font. Gradient descend. Yeah, that's a bit quick. Probably not the right one, so let's just quit. And again. And again. I'll just quit all of them. Okay, so here we have the approximation with a minimum here. This is the real function. And the approximation that fits in this minimum has a maximum here. It's just pure nonsense. But we're going to investigate it as if maybe, hey, who knows, maybe it is a cubic. So we're going to jump here. Not yet, apparently. No, it's first fitting a fourth degree polynomial, finding out that that thing does not have any maximum. And then jumping a little bit here to minus 27. That's like less than a pixel to the left. So I guess I can skip that one as well. Still a debugger opened. Good. Yes. And again. Okay, now I think we are there. This is the point at minus 9 million, right? So you did jump here now. And here is my debugger. Let's waste some time. So really? This function is called width. We're looking for a minimum. Okay, so this one is part of it. So these are the real values. So the parabola is at 1.7 times 10 to the power 13, and I think the expected value here is 5.8 times 10 to the power 12, so way less. And of course, you should detect that, see that this is not matching that one at all, and therefore return disconnected from skill update. Well, the whole code doesn't even contain a disconnected, so it's not going to do that. But I want to see what happens anyway. Debugger. Frame. How many samples did we see in total? Well, more than 2, I think. Yeah. I'm not understanding quite why we're still looking for a minimum, though. Already found the minimum, so we are definitely looking for a maximum. Or maybe this is not what you're looking for. It's the critical point type of the extreme that our approximation is fitting. Yeah. So this is the approximation at the moment still. And it is fitting a minimum. That's what that minimum is. Okay, and then I correct it, as it were. Let me make the font of this larger as well. The extreme types of this scale and whatever algorithms are looking for should correspond. Well, whatever, but I'm certain that it should be looking for a maximum. Next extreme type cannot be a minimum. Dude, we just found a minimum. Why? Is it another bug? I want to know where that comes from. Your next extreme type is a minimum. Print it anyway, although we already know what it is. That is in this file. The source code. Piece on top apparently. New top. Next extreme type is just set to what a critical point type is. Critical point type is the type of scale, which I'm pretty sure is what I described just. That's the thing that is being fit. So it's not next then. What was I thinking? Critical point type. whether distances are measured relative to the minimum, maximum, or the inflection point. Yeah, so this is the type of the scale that should be minimum. That's true. So the critical point type is minimum, okay. Now we set next extreme equal to the same value. I think it's just a hack, basically. This is the right way to call it. After yeah, I don't know. This function just takes a next extreme type, and here it's being set to whatever it needs to be set to avoid an assert or something. I don't know, let's ignore it. It's clearly set to minimum, but the name is a bit Oh, right, wait a minute. No, I'm getting it. Normally the approximation is used to find the next extreme. So the scale belongs to what we're looking for. Yeah. Let's see. So because this is an update of a local extreme, it's an extreme that we already found. Therefore, it now is not the next extreme type. It's the current one. So I definitely should rename this one. But then in update of scale itself, it's called next extreme again, which is yeah, confusing to say the least. No, hopefully that's enough then to avoid the confusion in the future. Where was I? Let's go back to the debugger. Yeah, 2. The cubic is copied, although I'm pretty sure it is already set to the same thing. It's just the same thing, nothing changes. New critical point, W means the x coordinate, is Well, if we have two extremes and the type is a maximum, then we need extremes 1, otherwise extreme 0. So it's not really new because nothing changed, but then this would be the -7 3/4. You really can't read it on this scale. That's the minimum, -7.75. That's where the minimum is. And debug output, yeah. Current sample. What the hell is that? Find the first element in samples that has a W value that is larger than current. And then insert current in front of that. So, yeah, might as well. No, let's print current. So yeah, that's the thing at minus 9 million. And then this, of course, are the real values. So if you look at this. So this is current here, the W coordinate anyway. And LW here is the value of the real function. That's this parabola. So that's way up there. So a lot larger than this number. And well, that's correct. So yeah, this is also weird, man. I mean, for some reason the minus 7.75 is not in here. What? Previous sounds like there's nothing else in between, but we did find the true minimum. Well, not true minimum, but the minus 7.75 something. And that was already considered to be close enough to this value to consider it a minimum. But that value then was never passed to the approximation. So the approximation doesn't know anything about it. It's kind of weird, I think. Isn't it? Well, they are supposed to be very close together, so might as well use this instead of the other one, I guess. They are close anyway, in terms of approximation, I mean. So this should be false. We're moving away. And critical points becomes the new critical point. I think it is already set. This is just the same value. And back some. Oh yeah, there's a quick test. What is in the back is less than or equal W. then that must be at the back. Now that's probably the case because W, wait a minute, W is super negative, so that's not the case. So this is false. And then this one is probably true. So we might as well insert it in the front end. Increase the right edge. And then if the front is true, it's just being inserted at the front. And index pointing to the new inserted thing. That's how it works. Well, not in this case. Should be size -1 then. If I want index to point to the just inserted thing. Or this must be -1. It should point to it in front of it. Yeah, in front of it. This one points after it even. Then this should be 1, but well, I don't know what's going on there. Next, at front, yes, place at front, index set to 0. Okay, now index equals the one that is just inserted. Value calculate, that's wrong. We should first filter out stuff so that we get the wrong value, but it doesn't really matter at that point. Now both left edge and right edge are set to index, which I'm pretty sure should be the index of the just inserted sample, so this is wrong. It should be -1. Let me fix that first before I forget it. 277 in I think I made a thinker here, because this looks like I was convinced that the thing that I just insert fits. That's not true. I think index should really be equal to the one that points to critical point, which is not there as we saw, because that would be the -7.75. But I could search for the critical point, then say let's have index point at first element past the critical point, and then we'll work with that. think that is the case if we do this or not. Let's have a look. List. Nope, nope. This one points to the first one that is larger than W. Instead of critical point. I need this for the insertion, but the index seems to be wrong. Or is it? Setting index to oh goodness, what a question, man. It's never finished, so it doesn't really matter, I guess, what you can use it for. I'm not a company trying to make money. I'm just trying to make fun, have fun. And clearly index is supposed to point to the just inserted elements. This returns 0 if iter equals begin, I think, yeah. And begin would mean where it is inserted, right? Iter is pointing to the... No, damn it, what the hell? It's also not true. This iter points to the first element that is larger than W. And now we insert, well, in place, but the same as insert, we insert before iter. That's why it is sorted. Okay, pen and paper. I'll type it here, you can see what I mean. And we'll edit as a comment. But index is done before This is assigned before the insertion. The distance is obviously then distance to that point. I would say 1, 2. Huh? So yes, the index is the index into the array of the just inserted thing. So if you put it at the front, then it must be 0, and if you put it at the back, then well, it must be size if you had done it like that. Now I do index and then in place. Yeah, I do index and then in place. So let's do that here as well. Okay, and then left edge and right edge are set to index. I have no clue why I'm doing that. This seems really wrong. Think left edge must point, is an index and must point to the leftmost element in the samples vector that is still matching the cubic. And it should start at a critical point, which was never added, which is really annoying now. I have to think about it. I guess I need a magic value for it. So the critical point is not there, but if left edge was pointing to the critical point, then it would be pointing to, well, then it will have the magical value. And my first magical value can be I don't need the index for left edge. I just need the index of one past critical point. Which I can initialize. No, I cannot. Well, I don't know. I don't want to keep. I don't want to add another find if really. Do I have to do every time? Maybe we can just update it. Critical point. I think it's the easiest way is to have a changing magical value, I think. Update it. Suppose we don't have any samples at all, then what value should these things be? Oh my god. Well, if we only have samples that are never to be pointed at, so let's say we only have samples that are less than critical point. For example, you just have one sample that is less than critical point. Then we should not point to it. So then it should not be 0. It should be 2, I think. So that is one past. Well, that's end basically. It's one more than the total size. So I guess it should be 1 if the thing is empty. Because, no, 0. 0 is pointing to nothing. 0 is, yeah, I just said it wrong, I guess. If we have one sample, it should be 1. So that is a non-existing index. The only existing index is 0. That's the only sample that we have. And then one more that is past that thing anyway. So it's kind of end in terms of indexes, equal to the size of the thing. So that should be 0 then. So the initialization is 0, I think, for an empty thing. And the one before are probably the same, but then as a reverse iterator, so but I'm not having a reverse iterator here. So it's different. Should it be 0 or -1? Well, if you have one element again, this index 0 is something, but you don't want to point to it, it should be -1. And now I can update these things as soon as critical point is known and something is added to samples. I hope that is done in the correct order. Yeah, critical point is set. Seems to be the only place where it is set. And that is the function update already. I think this is my initialization code. And we were not talking about the left yet. It comes afterwards, right? Well, what the fuck? Yep. So this is set to the top of this thing. It's definitely set before we add something to samples. This is totally assuming again that the thing that is being added is a fit. I mean, sometimes that is the case. Yeah, normally the thing that's being added is the last sample, is current, is used to update the approximation. So it is correct, except when this is the local extreme update, because then we did not change the approximation. I'm kind of using the same function for two different cases. That's where the confusion comes from, I think. So before we sort two relevant samples, it's impossible that we already found the local extreme. Therefore, then this is not a local extreme case, which I think I can assert. No, maybe not here. a minute. Oh shit. No, yeah. Sorry, I changed the meaning of left and right edge. That's why this is correct, and critical pointers have nothing to do with it. Yeah, no. So I don't know. Let's remove this. I don't think we'll need this. Yeah, this code only works if current was used for the new approximation. So I need to know when that's not the case. And then come up with some other code for that. And only that code would return skill update disconnected. That's why also this is not doing that, not returning that. Okay, how can I know if this is a local extreme? I think I cannot. Yep, that can only happen when this, when it is not a local extreme. I could even change this. I could pause. Well, I don't know. I'm now pausing something fake just to make this assert not fail. Well, whatever. So this seems kind of pointless. If it is a local extreme, then it is already the same. This should also never happen, obviously. So I don't think this is necessary because well, you already have it. There's no need to calculate this again. As if that operator exists. So now new GP is not initialized, but we never get here because of this assert. I'm not sure if the compiler knows that though. be unused. Yeah, and we should not do this either. In fact, I don't see the point in inserting it at all. Or do I? Well, since the approximation is not changing, I might as well only insert it if it fits. No, let's just do this. I made so many changes now already. Now let's rethink this. If local extreme, do this, else do this. To be honest, I would expect this to be true if this is false and the other way around. Or is it nonsense? No, well, yeah. I can't really think of a. Well, maybe to a GP. Maybe you should just get rid of this and use that. Kind of depends on how the return value is being used in terms of towards and away from. I think I'll investigate it. Not used at all. Well, not here anyway. What the hell? A result is passed to the trigger here. Oh god. It's used for drawing. That's it. Nah. Gotta be kidding me. Is that really it? And they're treated the same even. I think this is the only place where it matters. To draw or not to draw the old problem. Might as well use the other boolean then. So that would be this line. I mean, the other one was called what? Away from. Yep. Ja, nou ja, oké. So in this case, current must match. Therefore, we might as well start at that point and then search for the sample that deviates from it. That's the thought here. But I feel tempted to add an assert to test that this is correct. Maybe. Was Cubic already updated? Apparently. So we have a W value of the current. We calculate cubic at that point. It should be equal at the current W. LW should be equal to that, right? With an accuracy of, well, pretty accurate, I think. So let's see when we get here. AKA a compiled test. Yeah, like I said, like that operator exists. So I don't have an operator equals for math cubic polynomial. Guess I'll just have to add one. Yeah, that's not going to work. Comparing floating points like that is. Or is it? I mean, in this case, I just want to compare them exactly. Right? I just want to know if one is an assignment of the other. It's kind of a silly operator. Maybe I should make it a debug operator. Not exactly though. Wait a minute. I need this when asserts are turned on. That's an ifcw debug. Here compiles. Okay, so let's run this. What am I looking at? Couldn't find it. Okay, wait. Gradient descent. That's what we want. Okay, can I understand this? No, well, no, not really, but do it a little bit slower. Still have the cubic here, with the maximum here. It's going to jump to that? I suppose so. No, it's not. Maybe something interesting happened. So this is found. Now it should say that we found the maximum. Minimum, I mean. Minimum reached, yeah. So next extreme type toggle to maximum. So now we're going to look for a maximum. I do the past extreme no zeros again, which is minus 12. But before I had minus 27 or something because I did it too soon. Which is returned, and then we are here. No idea what this is. What is fourth degree polynomial? No, all this blue here. Strange. Yeah, I don't think we're even going to. We should wait, and I don't know. It's going to say we're not going to jump to the 9 million, minus 9 million again. Or are we? I don't know. Just have to implement this, I guess. Uh-oh, right. Yeah, I think I have to. Well, I have to insert it anyway. So this whole block of code kind of needs to be done. That's the insertion part. which edge? I have no idea why I was incrementing yet. Yeah, so this is only needed when local extreme is false, and this is only needed when a local extreme is true. But to edit and test for that seems a bit silly, but we'll do it always. Except when you already have a test, of course. Well, that's not true. Could add it here, and then you have to add it there again. It would still be a separate test, really. So now here I have to test if the current fits, and if it does, then include it. If current matches, then it should be we should never get here in the first place. I think that if it matches, then then why would we even trying this unless we're right next to the last edge that also matches? left edge. I know these stand apps are bullshit, right? It's just one less than left edge. Okay, well this current matches. Well, that's this whole code block here again. function that was changed. No output. Okay. Here's the scale again. -12 was added. Obviously. I mean, we call this with the -12 stuff. So you get that back here, and left edge is, can't find it, 0. Okay, so it was accepted as matching. And then we just abort because that code was also not implemented yet. I think it's time to go back to a graph without the billions on all sides. What? What the fuck? Yeah, maybe already. So I'm returning -12 here. And then I get what? I don't know where I was pointing, but the -12 is there. What that was stored. Yeah, okay. And there's the left and the right edge. They're also shown. Approximation is the 12 again. Left edge is 0 again. And the 3 means, well, 0, 1, 2, 3, yeah. -3.5. And then we have, and the cubic is now this maximum, but who cares? Handle approximation, this code is not implemented. Well, okay. Do I understand why this is not implemented though? I think we should just jump here and then there, and then there, and then give up. I'm just going to remove it, I think. The only alternative would be to, add a boolean or some kind of weird magic value for a new W, so I know that it is initialized. And I don't feel like either. Yeah. Not yet. Why already? So the problem is that the loss region is equal to in between. Yawn. Yeah. Yeah, I think I'm gonna have a break. It's still nice weather, so I'm going to eat my lunch outside or something. After losing a game of chess because I can't get up. My rating is so low. It's really unbelievable that I keep losing stuff. I mean, I don't think that usually when I saw an opponent having 1800 something, I would just never lose. It's just cat in the bag, how do you call that? You just win. But these days, hello Anoop. No, this is how I know my 1800 players again. Like, too easy. I guess that's the best move. Can't take it. Well, it seems completely ridiculous. That way even. Doesn't even want to attempt to. capture my bishop. Now I think I threaten my rook here and then put my queen here. So I don't have these squares like with a lot of times. And I take this point. I can't put anything in between. Okay, now I can't do this. I guess I have to cancel because this is attacked. Your castle is fine, isn't it? What is this guy doing? Wanting? I don't get it. At the very least I get another pawn if I push my queen now. I can block on this square. Oops. Oh, really? What am I doing? Yeah, that's why my rating is so low. Okay, now I have to play him through the clock. Horrible as it is. Oh shit. Really? Really, really? He's still not losing on time. Pretty unbelievable. Yeah, these aren't even. Well, that was something. At least I didn't lose, although, you know, I should have. And then, of course, the sun has disappeared again. Fucking sun. Yep, I'm going to eat lunch and stuff.